particular solution to the differential equation with the initial condition f of -1 equals 2. On the axis provided, sketch a slope loop for the given differential equation at 12 points indicated.
Okay, let's start by making our triple T chart. And that's representing our x, y, and m. I didn't need that part. I need x, y, and m. Oops, I had one extra. That's my boo-boo. All right, so from there, let's kind of analyze and see where I can be clever about this. If my x is equal to 0, my slope is always what number, no matter what the y value is? 0. And then let's go further. If the y alone is 0, no matter what the x value is, the slope will always be what? Undefined. There's a 2. 0. So that means anywhere I see x equals 0, I'm going to put in our 0 flat part. And then I'm going to go across and put a flat line. Maybe I can use a different color. The blue is not very evident. All right. So then we want to figure out what is happening at 1, 1. So if I plug in the 1 for the x and 1 for the y value, isn't that negative?
Yes, negative.
Okay, so it's going to be -1/2. Do we all see that? So I'm going to make my line like this. Okay, I'm going to give y'all 1 minute to go ahead and plug in the other 5 points. Go. Plug in the other 5 points. Again, it really doesn't matter how steep it is. Just make it a little bit steeper. I'm not looking for the accuracy. So, on this one I did because it's not a circle. Now, if it was x and y on the top and the bottom, then you can. Is my slope to the right of that steeper or less steep? It is steeper. And on the top is a little bit steeper as well. And even more steep on that one. As long as it's giving me a negative slope, that's all I care for. It's a little more flat and steeper right here. All right, let's go on to part B. Charlie, read part B, please.
Write an equation with the line tangent to the graph of f. Is it a prime?
Graph of the f at,
It was my pencil. Never mind.
that's okay. X equals -1.
Of f at x equals.
There you go. Okay, let's go ahead and underline the equation of a tangent line. So equation of a tangent line is going to be y minus y1 is equal to m times x minus x1. The nice thing is we already have our point for my x-coordinate. What's the x-coordinate given? -1. And then what's also nice is at the beginning it says when x equals -1, y is what number? So if you're like, oh no, they didn't give us the equation, how do I solve for it? Typically it's given to you, if not, giving you the equation. And then we want to find the slope. Isn't the slope equation already given to us on the top? So let's plug these two numbers in. So we have negative of the x, which is -1, of the y squared, which is 2 squared, all over 2. And that's going to be a positive number because 2 negatives become positive for sure. What is 4 divided by 2? 2. So our final equation basically is, I'm plugging them in into my y1 here, my slope here, and the x, which our final equation is y minus 2 is equal to 2 times x plus the 1. Did we really apply calculus here? You can't miss that question. Now let's do our particular solution. All right, Nev, go ahead and read the last part, C.
Find the particular solution, y equals f of x, to the given differential equation with the initial condition f of -1 equals 2.
So let's start by writing the equation given to us. They gave us dy over dx is equal to -x y squared over 2. And just like I did on the notes, we are going to cross what? Cross multiply. And then we have to judge and see, is it separated all the way? So I have on here, we have 2 dy is equal to negative x y squared dx. So we have a problem here. I know I have to solve for y, correct? Give me a nod if you know we have to solve for y. So is it a good idea to keep any non-y values over here? I'm going to bring that over. And then it'd be a good idea to put the y squared on the other side. And by that I'm talking about, we have, I'm going to move the y squared over, 1 over y squared dy. And then I'm going to move the half in front, negative 1/2 x dx. Now I have all the y's together and all the x's together. If you're good with that, give me a thumbs up. Okay? Now we are going to integrate on both sides. Okay, when I'm integrating on both sides, I want to do some side notes real quick. Or maybe I'll just write it together. Let's go ahead and bring the denominator to the top. So we have y to the negative 2 dy. And then for the next one, we can go ahead and integrate right off the bat. What is one more of this power, guys? 2. So I know I have to divide it by 2. But since I already have 1/2, are we okay if I just write 1 over 4? Okay? And then I have x squared. And only put c one more time. And notice I did not do anything on the left side. Because on my left, all I did was rewrote. So here I go. Let's apply our calculus then. What is one more of this, guys? Negative 1. So we have y to the negative 1, 1 over the negative 1. Are we good on that? Okay. I am going to rewrite that piece on the top over here. When I rewrite, that's going to give me, is that 1 over y? Negative 1 over y is equal to, and leave everything on the right side as it is. So is everyone good with why I have negative 1 over y? Okay? So from there, my goal is to solve for y. So let's see if y'all maybe remember. If you were in my geometry, I use this quite often. What did I do, if y'all remember, when I had all divided by that variable with the other side? What was the rule that I applied back in the day? We switch them. So when I switch it, I'm going to do 2 things at the same time. I'm going to put the y over here, and we have negative 1 over negative 1/4 x squared plus c. So all I did was I switched it, but because I knew I was solving for y, I kept my y on the left side. Everyone go with that? Okay? Now, from there, let's see what's happening. Can I plug in our values that are given to us? So initial condition of negative 1 and 2. Let's plug it in. We have our 2. Negative 1 over negative 1 over 4. Another negative 1, all squared, plus c. My goal is to find the value of c. And then I'm going to do that same rule again. Do y'all see my variables all on the bottom again? Can I switch it again? Most definitely. Let's switch it. So we have negative 1 over 4. And watch what I do. Because I know negative 1 squared is going to be 1, I'm not going to consider that value. So we have, from here, when I switch it, what do I get? Negative 1 over 2. Now we're going to go ahead and apply some algebra. We're adding 4 on both 1/4 on both sides. So what is the actual c value then? Because think of negative 1/2 is technically negative 1 over 4 plus 1 over 4, right? Or 2 over 4, I mean. What would that give me? Negative 1/4. Any questions on this guy? Good? So now we can go ahead and rewrite this with our solution. So let's draw this arrow and say we're going to plug just a c value in. So our final answer is y is equal to negative 1 on top, negative 1/4 x squared, and then we have minus 1/4. And that is our particular solution. So let's kind of label. This is our particular solution. And then right down here, over here is our general solution. So general solution has the variable x, y, and c. Particular solution has just x and y. If y'all are good with that, give me a thumbs up. Okay.